Okay, welcome back. We're going to take a look at the next step in comparing our linked list and array list architectures. We're going to do that by building out our linked list. The first thing that we need to do is we need to create a node class. The node class is going to be used within our linked list in order to hold data. Now, while this will eventually be a private inner class of the linked list implementation, initially we're going to create it as its own separate class so that we can do a test for it and make sure it does the correct thing. All right, so let's switch over to Eclipse and build this out. All right, I'm in my Eclipse implementation now, and I'm going to create a new project for this. It's going to be a Java project, and I will just use the wizard to build it. I'll call it List Comparison as my project name. And everything's good there. The only thing I need to do is to my properties and my Java build path, I need to add a library, which is the JUnit 5 testing framework, and that will enable me to do some tests for my node as well. All right, so now the first thing I'm going to want to do is I'm going to want to create a new class, and that class is going to be called node. And it doesn't need anything but the node class, and we'll open it up there. Okay, so our node class is going to just contain a few elements. It's going to contain just enough for us to keep track of the data, and we'll do a doubly linked list in this case, and so we will have the opportunity to do links forward and backward. So in principle, what we're going to do is something that looks like this. Let's see if I can kick over to a sketchboard for you here. All right, so we're going to have something that each node will look something like this. Pardon my poor sketching. You'll have a reference to some data here. You'll have a reference to the next element and a reference to the previous element. We'll create several of these nodes. Data, next, previous. The next will point to the next node in the list. Previous will point to the previous node in the list. When you get to the beginning of the list, this will point to null. And when you get to the end of the list, the next pointer at the end of the list will point to null as well. There's the data, there's previous points here, and next points to here. All right, so each one of these is a node, and that's what we're going to implement right now, one of those node classes. All right, so let's see. Turning back to Eclipse, we have node class, and we want to add things to our node class, and what we want to add is that data that's going to be where we're going to store those different references. So like a good chef, I'm going to bring in the pre-cooked version here. And what we're looking at then is, let's see, we are not importing anything, we're just using our own class here. And we have the default package. All right, so the first thing we have is we have the data that we're keeping track of. That's called data. It is of type object, which means that which is going to be any generic data we want to keep track of. We have a link to the previous, and notice that's a node type as well. So this is a reference to the next node in the chain. Previous node in the chain. And then next is a reference to the next node in the chain. Well, any good class needs a constructor, and so we're going to add a constructor to this class as well. We'll drop this in here. Our constructor is going to take data, a previous, and a next node, and it will just call a superclass. We don't really have a superclass, but that's good, just good practice to call super. Again, as we import these, we're having a little trouble here. And we're just going to say that the instance data located here will be initialized to the parameter that's passed in. So we're just moving the parameters into the instance variables to keep track of things. Previous will be assigned this.previous, and next will be assigned this.next. That's basically all we need. So all we need to add then to that is getters and setters. So let's first work with the data object, and we will grab the getters and setters for the data object. So once our instance class is in place, if they have a node and would like to get data out, because data is private, they can't get it, and so we'll provide them a getter and a setter, which are public. Get data will return the internal data, and set data will set the internal data. So far, so good. We need to do the same thing with get previous and set previous. You can add those in here. Simply a getter for the previous reference and a setter for the next reference. And then finally, we'll do the same thing with get next and set next. All right, we'll save that up. Everything looks okay. I've got an error because I have a bad package. And what I would like to do is go ahead and name that package. So we'll say this is going to be edu.westmont. And we don't want to import anything. We just want to say that's the package we're in. And then we'll ask Eclipse to move it to that package. Over here, we can see that it has moved it to that package, and so all our errors go away. Now, if we're a good software programmer, we're going to make some tests to make sure that we wrote this code correctly. Little bug there. So I'm going to go ahead and create a node test as well. This is going to be, I'm going to highlight node, and I'm going to say new JUnit test case, and it'll be node test. Great. Next. I have some pre-cooked ones, so we'll go ahead and put that there. I'll pass node test over here, so I have it side by side so we can see it. And you can see that we now have one test that will fail no matter what. So just to prove that, I'm going to right-click on node test and do coverage as a JUnit test. This coverage is provided by a plugin called Eclemma, E-C-L-E-M-M-A, and that allows me to see what code gets run when I run a test. So I'll run a JUnit test. See that it failed here because we have blue for the failures, and we can see that it failed because we hit an automatic fail. Right, that's not what we want. We want to be able to evaluate how this node works, and so let's start by just changing our basic test to make sure that our constructor works. If our constructor works okay, then if we create a new node, even though we're passing it in null references, this should successfully create a new object without causing any exceptions. If it does cause an exception, then we'll fail. If it doesn't cause an exception, then we'll just pass through this try block and this code will run without any problem. Let's see, we've got a problem here with our imports. Let's clear that. All right, and now when I run my test, we can see that over on the right side, I have called my constructor. Let me reopen my constructor code so I can see, let me reopen my node code so that I can see the color coding. Great. All right, and you can see that while running the test on the right, I created a new node object, and because this is green, you can see that running those tests caused this code to run, but not this code because this is highlighted red. That makes sense because we never called getData over here. What I'd like to do now is to test the getters and setters. I will grab a test here and we'll walk through it. This is basically going to test all of our different setters and getters. So let's walk through here so I can show you what we're doing. Test getters and setters first initially gets 4 strings, S1, S2, S3, S4, just available to us so that we can pass them in and out. And then I create 3 node types, node 1, node 2, and node 3. When I create them, I pass them the string that I want stored in the node, S1, S2, S3, and references to the previous and next node, initially null. So these 3 nodes exist without any chaining between them. So if we were to shift over to our sketching, what I'm doing is I'm just creating a node like this that has data in it, but the previous points to null and the next points to null. Oops, sorry about that. Let's clean that up. And go back to Eclipse. All right, so we create those 3 nodes. That's our constructor. And now what we're going to do is we're just going to make sure that our getters worked. We're going to call the getData on each one of those 3 nodes and make sure that the data that we get back is equal to what we thought we set it to up here. That's just a test to make sure that we stored our data correctly. Then we're going to check to make sure that our previous are all nulls and our next are all nulls. They better be because that's what we set them to in our constructor. Then we're going to test our setters. We'll set each one of our data equal to something new. N1 initially had S1 as data, and now we're going to reset it to S2. After we set each one of our nodes' data to something different, we're going to now check to make sure that when we get data, it is the new different thing that we saw. Finally, we're going to adjust the previous ones, and now we're actually going to create a chain. So N1's previous is going to be null. N1 will be the beginning of our chain. N2's previous will be N1, and N3's previous will be N2. So walking backwards, we go N3, N2, N1. Then we'll just call our getters to make sure that that actually took. Then we'll set our next, and we'll say n1 is next is n2, n2 is next is n3, and n3 is next is null. We'll validate that those took, and if all goes well, when we run our JUnit test, we'll see all of our lines in our node class become green. Very good. We're concerned of the left side that all of the lines in our constructor were called, all the lines in our setters and getters were all called, and we passed all of our JUnit tests. So we have very strong confidence that the node class at which we just created does the basic job of keeping track of our data, our previous, and our next. That's the first step in implementing our linked list implementation, is creating a node class. We'll come back with the next step in creating our linked list.